Good morning, everyone. Good morning. The Unity version does not matter. Somebody just asked in the chat. You can click the little button that will say, update this version to my current version or whatever it is. It's not going to do anything. There's been no significant changes. Speaking of assignment 1, we will be going over that in this lecture a little bit later on. But we haven't even reached the beginning yet. Still 2 minutes out. To access the code and edit it, to do what we need, do I have to have Visual Studio on our PC? You don't have to have Visual Studio installed on your PC. You can use anything that you like to edit the 2 scripts that you'll need to for assignment 1. But I do recommend it, as you'll actually be able to get error messages in Unity, which will be helpful for debugging that you wouldn't otherwise. So I do recommend installing Visual Studio, but it's not technically required. Good question. A couple extra good mornings and hello, good morning and hello. All right. I'm going to end up having to let people in a little bit more staggered today, as we have a lot to get through today, so I want to actually start closer to time. Okay. Give it another little bit, but I'm not going to wait till 11:05 or so today. Okay. Hit about 5/7 of the class, that classic fraction that everybody knows so well. So I think that that is sufficient to go ahead and get us started. So with that, I'm going to swap us over to this and this. Okay. All right, so we're going to start today by talking about grids. This is our first actual sort of topic lecture. We talked a little bit about game AI, right? Sort of broadly in the very first class, but this is our first actual sort of technical topic, and we're really going to sort of get you a slow start. This isn't that complicated, but it will introduce basically everything you need for the main section of assignment 1. So with that, let's go ahead and get that started. So some quick announcements. So the first participation grades are up, rather the first participation grade is up. Everyone got points for the first quiz because we hit 70. So I'm fine with that. Everybody gets points. Homework 1 will be released today. In fact, it has been released today, and it's going to be due. Oh, that's not the right one. That was for the winter. My bad. So that it's going to be due in about 11 days. I think September 18th. It's on eClass. Now, notably, you have a grace period afterwards for 23 hours, but every 10% you lose 10% every 24 hours after the deadline. But if you think that there's going to be some issue for some reason with your getting the assignment in on time, if something comes up early, please let me know. If you give me a few days warning minimum, I am much more likely to say, sure, that's fine. Here's an extension. Just talk to me, right? I really would rather hear about it ahead of time versus you emailing me, a day or two late and saying, oh no, I had something come up. Because at that point, it's much harder for me to believe that. Yes, it's due on September 19th. Or let me double check. I want to say that actually they give you the exact right answer, because if I give you a slightly wrong one, if I say something wrong now, people are going to be like, oh, but you said it was this. Right, so it is due September 18th on the Friday, 11:55 p.m. That is the deadline. But again, you have 13 hours or 23 hours after that. So sure, it could also be considered to be due on September 19th at 10:55 p.m. Whatever works better for your head to get you to actually motivated in doing the assignment. I am fine with whatever on that. Okay, so beyond that, today we will have another lecture quiz or participation question. On Friday, we're going to have what I'm going to call a practice quiz. This isn't going to be a real quiz. It's not one of your 6 actual quizzes, of which I'll take the top 5, but it will give you a sense of broadly what kinds of questions are there going to be, and broadly it's going to give you a sense of what you're going to have to be considering for a actual quiz. So that will be on Friday. It'll take a little bit longer. It's going to be like the last 10 minutes of the class or something like that. So be prepared on Friday to actually do a little bit of in-class stuff beyond just answering one question. Any questions on any of the announcements beyond the due date stuff already asked? Looks like no. So I'm gonna go ahead and keep us moving right along. So in the last class, well, the last 2 classes really, we did a discussion of game AI and about how he's interested in simulating believable behavior with minimal resources. And we talked about how game AI covers any decisions made in and around a game development not made by a human, which includes things like data science, which includes things like PCG and all kinds of stuff like that. And of course, we did a very basic introduction to Unity. I will give you a little bit more detail on explicitly how you're going to be using Unity in this class today when we go over assignment 1. Okay, so movement in games. If your game requires any representative space, whether it be 2D or 3D, or there's some weird new 4D games as well, entities must be able to move through that space. Now, this creates a problem. How do we go about figuring out how we can go from our current location to some target location? That might sound extremely easy to you. You might think, oh, I move all the time. I go across my room. Et cetera, et cetera. But it's actually quite challenging. And that's sort of the crux of this first topic here in game AI. Now, you might think, hey, isn't this solved? Why on earth are we talking about something like this? Well, no. There's 4 examples here, but I'm just going to show you the very first one. There's E-Class. Hello, E-Class. This is an example of Mr. X from Resident Evil 2. There are subtitles on this, so I don't need to play the sounds. And this is showing a fun example of Mr. X, who's this big, terrifying, sort of trench-coated figure who's following the player around and is going to be chasing you in the library. So let's see how this goes. Uh-oh, okay, so we're climbing up. This is Jill Valentine, the player character, or one of the 2. Uh-oh, worried about where's Mr. X. Oh, there he comes. The bald man over on the stairs, coming over, and uh-oh. That doesn't seem right. That's an interesting thing that this person just put in. He can see me, but he can't reach me. So that's actually a fundamental misunderstanding of how game AI works. Game AI never sees. There's no notion of perception. We'll talk more about that in just a bit, play a little bit more of this, and we'll jump back into the slides. Okay, so this is going to continue for about another 2 minutes. I don't think we need to go on for that long. So here's a first question. What do you think is happening there? Why is this so difficult? What's going wrong? If anybody would like to put some ideas in the chat in terms of what they think is going wrong in this situation. Any ideas at all? The AI's path only extends to the right in front of Jill. Sort of. Shortest path algorithm gone wrong. Not quite. Not a proper grid point where the player is standing. Hey, Mike gives us something very close to the right answer. Is because the player reaches the point that is not recognized by that AI. Yes, Dongheng, it is the right kind of answer, but not technically what's happening, right? The spot is out of the scope of movement for the character. All right, Rakov, now the scope of movement is not the term we're going to be using, but you're dang close. There is no direction for what to do once the object reaches the target location. That's not quite right. So the earlier bits here, the idea that people had was basically that the space representation that the agent is moving in is different from the perspective that we have in terms of what the sort of world looks like, what the world of the game looks like. So the AI's perspective, the AI knows about areas that the AI can traverse, where the AI can walk safely, and about areas that the AI can't walk safely. Those are the only 2 things that the AI knows about. Now, in the case where that space representation, where the AI thinks they can go and where they can't go, doesn't match up with our notion of the space, that's when these issues come up. Specifically, what they were using for this game is a nav mesh with a path network. So there was a point, so there's a series of points that the AI knows about, that the AI can be, that the AI is legally allowed to be. And that point goes just before that edge there. Probably because the point was automatically algorithmically produced. And so there was no notion of like, oh, hey, there's actually a little bit more room that you can get to there. Would that be considered a bug? Sure, though in this case, it's not because the code is necessarily wrong. It's that the algorithm did not cover the sort of game design needs, right? But in this case, it's not like there's an error going on. Okay, so let's move on a little bit. Let's think about this a little bit more abstractly. So if this isn't like clicked for you yet, let's think about it this way. Imagine you're in a giant white void, okay? There's nothing else in this void, nothing as far as we can tell, at least right now, okay? You know where you are in this void, okay? But all you know is the point, your position, in terms of a 3D or a 2D point, right? So like a Cartesian space, you know where you are, okay? You also know where you're trying to go, okay? In this case, this black dot here instead of this blue dot. I don't know why I keep saying okay. In addition, you can know the velocity that you're moving at. So you can know, if I update my velocity in this way, right, using just linear algebra, can I go from this position to this position? Will I eventually hit there? That's everything you know. But what if there is some kind of block in the way? If you, in this case, you're an AI, if you are not explicitly told about that block, you can't avoid it. You're just gonna run directly into it. Has anybody seen any games in which an AI character just like walks into a wall continuously? Seeing some nodding in the chat. Okay, so there's a suggestion in the chat that you should just go around it. How? You don't know about going around things, right? We don't know if there are more obstacles. GTA 5, yes, that's certainly an example where this happens, right? So we don't know if there's more obstacles. It could be that maybe in the past there weren't obstacles in these positions, and so the AI didn't know about them, but now there are obstacles in those positions. So yes, so there's an example in the chat from Hanan of sometimes the AI in GTA 5, you could run into a wall or something like that and then show up on the other side. So cheating is a valid way to solve this problem, but it's not a great way because if the player sees you cheating, it breaks immersion, right? So we don't want to have to cheat our way around this situation. We want the AI to behave in a way that looks reasonable, right? It's the whole thing with game AI. We want something that looks reasonable and with minimal resources, okay? Now the easiest way to do that is going to be to represent our space in a way that the AI can actually know where it can move freely, where they cannot move freely, and how to move between areas of one. Does that make sense? So let me give you an example real quick. Let me actually do this. So grids are a great example. And in fact, it's the topic of assignment 1. So with a grid, right, we know that in any position on the grid, that's a valid position that you are allowed to be in as a game character. And that you can move between the grids in terms of the neighboring positions on the grids. So lots of games use grids, right? Into the Breach, which was a Tactics game that came out, I think, 2 years ago. Fire Emblem Three Houses, very recent, fancy 3D tactics games, but in fact, it uses a grid, which to actually represent it on the world. Super Mario Maker 2 uses a grid for its design. Baba Is You, recent puzzle game, uses a grid. Lots of games use grids, right? The nice thing about a grid is that it is a 2D tile representation that's mapped generally to like a floor or the ground level. They're gonna generally be like a square or maybe a hex cells. Then you're gonna have 8 or 4 neighbors in terms of your connectivity. So this is giving us, I as an AI can be in a grid position. Being in a grid is valid. And in terms of how I move between valid positions, I know that I can just take any sort of shared side between 2 neighboring grids, right? 4 if I can go up, down, left, and right, and 8 if I can also go the diagonals. Cool? Make sense? Wait a few seconds. Vamp for time, see if there's any questions that pop up in chat. Not quite. So that caused the bug in the last game. So Zayu, the last game was actually being caused by a nav mesh issue, not a grid. We'll get to nav meshes later on, and it's the extra credit for assignment 1. Yeah, so if you see a tile map or anything that looks like a gridded pattern in a game, it's using a grid. So if it's confusing still, you can think about it as basically, let's go back to that earlier example, right? So if we had a grid here, instead of just this empty space that told us nothing, then we could, for example, know something like, okay, so it is, let's see, let me grab this, and let me grab this. We could know, for example, that it is valid to move like along this path here, because this path here is a series of grid cells. I don't know if I'm going to be able to actually draw in. Oh yeah, there we go. Hey. So if these are, this is a grid. I'm not going to draw in every single point of the grid because it's quite difficult to draw these. But, right, so if this is a grid cell right here, then I know that I could go from my current grid cell to this next grid cell, and then to this one that I just made. And then I could go to the one to, oops, don't want to move like that. Here we go, I'll just zoom in. Then I could move to the one to the right of that, then to the one to the right of that, then to the one to the right of that, et cetera, until I've fully moved around this object. And then I can proceed to my target. I could copy paste the cell, but the way that I did the line, it wouldn't actually copy paste cleanly. Does that help at all in terms of thinking about how we can change from sort of an unrepresentative space where we don't know anything to a representative space where we can know where we can move freely? This is basically telling the AI how to move around this object. All right, I'm not seeing any more questions popping up in chat, so I'm gonna move on for now. If you're confused, I do recommend you can check the reading, the optional reading, which is in the Game AI textbook, talking about grids and other space representations, which goes over this in a little bit more detail, but hopefully it's fairly intuitive, at least to most of you. Okay, so let's go ahead and move on from here. So we had this notion of one entity in the cell. It's a nice way to simplify our space, that we don't have to worry about sort of thinking about space in terms of being various different sizes. Everything is nice and uniform. It's great then for like puzzle games and things like that. I'm not quite at the right thing. Now moving on a grid is a little bit different. So when we're moving on a grid, we're generally going to take whatever our current cell node is. So say if we were in this like top left position up here in this corner, for example. If we're right here, then we know that we could go to our right or we could go down, right? If we're allowed to move along our diagonal, then maybe we could go here as well. But we know that we can basically transfer between these different grid cells. And then once we're in our new grid cell, we're also in a valid position. So if we're trying to go, say, from this top position to this bottom position, we can just keep on going from the current position to take the next closest cell to our goal position according to some heuristic, like the straight line distance, for example. All right. Now, greedy grid movement can be pretty fast. So for example here, now this isn't perfect, right? Because we're not allowed to move along a diagonal, but in this case, it's a pretty fast example. Oh, I should say, we're going from our red starting position to the blue goal position. If anybody, I don't think anybody's gonna be red-blue colorblind. That sounds unlikely. But in this case, in any case, it's the top sort of left square to the bottom right square. But also, greedy grid movement can be very slow. For example, if there's an obstacle in the way. Now, this is very much like our example from earlier. We don't necessarily know that the obstacle is there before we get there. We just know where we can't go, which means that we have to go all the way from this top left position, explore all the way down here, and then make our way all the way back here before we can figure out, oh, okay, the right path is to just go around the obstacle. There's ways around that, sort of virtually exploring instead of actually sending your character forward to explore. But in the worst case scenario, you can get something like that. So any position on the grid is a valid position on the grid, but the grid isn't necessarily going to be totally uniform. So for example, this is a question from Raghav. In this case, the sort of gray, the dark gray blocks are not positions on the grid. So they are invalid positions. What if there are two equal options? Is there a preset tiebreaker? Kind of that's entirely based on the implementation that you're using. So if your implementation has a preference, cool. If it doesn't, it's probably going to be like random or something like that. But that's entirely based on implementation. There's no set answer there. Okay, with that, here is our first lecture question. I want you to name one pro and one con of using grids in terms of character movement or navigation. I will also go ahead and drop the everyone in meeting. I will go ahead and drop the link in the chat. Oh, did that copyright? I guess not. Oh no. Well, I can just copy it by hand, though. That's kind of weird. Oh, it's because I highlighted it. I didn't actually. That's very funny. Let's do this. Copy, and then there we go. Boop. All right. Take a few minutes, answer those 2 questions, and then we can take a look at what kind of answers we're getting. Please be aware I will be showing your answers, so please don't be weird about it, ideally. All right, we've got 1 answer so far. I'm hoping we can get a few more so we can talk about it a little bit. Also, as a reminder, feel free to drop questions into the Discord instead of here if that is easier for you for whatever reason. All right, we got up to 4. Okay, here we go. Now they're coming in. 11, great. All right, I'm gonna call out some of these at random. So pros of grid movement according to y'all. It's very clear where you can and can't move, great. It's simple, easy to understand and implement. Largely true, we'll see how simple it is in just a second. Systematic and uniform movements, provides a clear-cut reasoning for movement in space. Yes, all of these are true. Streamlines pathfinding thanks to simplified geometry of grids. We haven't gotten to pathfinding yet. We will. When we do, that is certainly true. We know that a grid is going to be a uniform size, which means that path planning is pretty easy because we know the cost of every step. So that's certainly true. Let's take a look at some cons. So cons, without interpolation, movement can appear unnatural. Sure, so you're basically like jumping between sort of, if you're moving at a diagonal, right, you can get like a weird behavior from there. So you might need to, instead of sort of smooth the path, we'll get to that in a second. Abstraction of detail may lead to bugs. Not sure about that one. I mean, so it's certainly true that any representation can lead to bugs incorrectly done. But as long as you actually have the right representation, grids are pretty good in terms of avoiding weird movement bugs. You can't see where you can't go until you get there. That's broadly true. We'll get around how path planning can help us solve that problem. Requires more grid to represent more sided polygons. Sure, so if you have like a weird shape, then you need more grid cells. That's certainly true. In general, it's gonna take a lot of grid cells necessarily to cover an area, versus it might be true that a whole area is safe to move through, but you still have individual grid cells you have to traverse. Okay. So I'm going to go ahead and move on. There's some great answers. As a reminder, you have 48 hours from this lecture to actually do this question for credit. Okay, so let's go ahead and move on. So here are the answers that I came up with. Discrete space is simple. Yep. It can be, I'm going to not highlight. Let's not highlight. Here we go. Can be generated algorithmically at runtime. This is what we're about to get to. So instead of having to like hand design your grids, you can just generate them algorithmically, which is that there's no cost in memory. We don't need to store our grids, and this is what homework 1 is going to be about. It is also good for a large number of units. So under the hood, a lot of strategy games use grids because it's very clear that we can say like, okay, each unit should be in one grid cell. Versus if we don't use grids, if we use some other approaches, the units might end up sort of going one on top of each other, which isn't great looking. So for example, like, you know, tactics games like Fire Emblem, for example, all use grids for this reason. A-Star and Greedy Search works really well on grids since there's a uniform action cost and not many tricky spots. By that I mean going from one grid to another grid is exactly the same cost. It's always the cost of the size of the grids, right? Because they're always the same size. Then we've got some cons. So discretization like this wastes space. So as I mentioned earlier, it might be the case there's a whole big area that's actually safe to move through. But because we have individual grid cells, we think, oh no, we need to move for each individual grid cell one at a time, as opposed to knowing, oh, we can move through this whole area just in a straight line. As people mentioned, agent movements can be jagged or awkward or blocky, though they can be smoothed. Some genres need continuous spaces, right? So we can't use a grid cell which chops up spaces if we need to be like moving very quickly, right? I can't use a grid if I'm going to be like in some kind of first-person shooter, for example. That doesn't really make sense. Partial blocking hurts validity. We'll get to this in a second, but basically it means that if we have an obstacle which is partially obscuring a grid, there's no notion of making the grid smaller or reshaping the grid to fit that obstacle. Each grid has to be the same size. Search must visit a lot of nodes. While it makes search a good fit for this, it also means that search has to visit a lot of nodes. And that means that search spaces can quickly become huge. So 100 by 10 map means 100K nodes and 78K edges. That is a lot, right? All right, let's see if there's any pops up in the chat. Nope, okay, so move right on. Okay, so some new problems. How do we generate grids? And how do we determine if a grid cell is valid or not? How do we address things like awkward agent movement? And how do we address things like long search time and the odd behaviors with certain sort of world configurations or scene configurations? Well, first things first, here is some grid generation pseudocode. This is going to be pseudocode that you can use for assignment 1. Though you'll have to add actually quite a lot of detail from this. So let's walk through this. So from the top to bottom, the first thing we're going to do is we're going to iterate through every possible X position where a grid center could be. Then, similarly, for each X, we're going to go through every Y position where a grid center could be. So we're basically going through all rows and then all columns. And we're going to check and see, hey, if this grid cell was here, would it be valid in terms of the obstacles I'm aware of? So in other words, is it not intersecting an obstacle in any way? If it is, then we can go ahead and add this potential grid cell to our grid and then go ahead and return our grid. Okay? Really straightforward. Most of the complexity is happening in here, which we can talk about a little bit more in just a second. Any questions on this? Oh, because how does a 100 times 10 map by 100K nodes? Because we are not just unidirectional. I can go from each node to another node and then back to the same node. And so we're talking about expanding the search tree. By edges, we mean the edges of going between one node and another node in a search process. We'll get to path planning in just a bit, I promise. Any questions on this specific pseudocode, though? Can I please repeat the traversing? I'm not quite sure what you mean. Can you clarify? Can I repeat the pseudocode? Sure, I can walk you through the pseudocode a second time. So we're going to iterate through every X position, which is every possible grid position in the X dimension in terms of our world being our scene in our particular case, but it'd be whatever your sort of space that you want to put a grid in is. Then you go through every Y position as well. So every X, every Y, so that gives us every possible position that a grid could be at. And then we go ahead and instantiate what could be a potential grid cell here. And then we check to see if it is valid, meaning are there any obstacles that are partially intersecting this grid cell? And if it isn't, if there aren't any obstacles, so it is valid, then we go ahead and add this grid cell to our grid and return our grid. It's pretty straightforward. All right. Okay. All right, so by validity, so here are a couple examples of things that break validity. So in this case, in both of these cases, both of the grid cells that have this little icon in them are both not valid, which means that if we have an obstacle which has a line that cuts through our grid cell, that's obviously not valid because we have to have an entity that has to be able to stand anywhere in this grid cell or take up the whole grid cell, right? And that would no longer be possible. this little edge here on the sort of top right of this grid. So let's see, I can go ahead and just do this. There we go. So this position right here, where we're sort of cutting off the corner of this grid cell, means that this bottom grid cell is also not valid, because we cannot safely ensure that every position, every pixel of this grid cell is a safe place to be, because we could bump into the obstacle in this corner. Same with this situation over here, right? So obviously this is an issue. We have a point of the obstacle inside this grid, partially obscuring it. And we also have this issue down here where this sort of bottom, or this top right, the sort of slant of the obstacle, this diagonal of the obstacle is cutting off part of this grid cell. So in all of 4 of these cases, these are non-valid grid cells, okay? Oh, gotta admit. All right, go ahead and jump forward. So in terms of dealing with problems of correcting the agent movement, we can do path smoothing. So our default path is given by the sort of darker arrows here, where we go first to the right, and we can take this diagonal, then go over, then go up, then take this diagonal, oops, then take this diagonal, then go over, and then go up. But that's a little bit unrealistic, right? A real person wouldn't take a path like that. So instead, right, we can do something where we say, okay, well, what if instead we just look at cutting from each sort of edge of this path to the furthest edge we can get to safely. So from here, we could get to here. From here, we could get all the way to here. From here, we could get, from here, we could get all the way to here and then back up to here. So we have this like notion of smoothing out the path to try to make it a little bit more natural. We'll get into an algorithm for doing this a little bit later on. And then, last but not least, we've got a quick summary before we jump into assignment 1. So, summary here, grids are the simplest means of representing space in games to split navigable, so where can we be, and unnavigable, where can't we be, space. Grids are nice for many AI units and are well suited to path planning approaches like A*STAR. So they're good for things like tactics games or puzzle games. Grids, however, introduce a host of problems, including awkward, unrealistic movement and issues around the search space. We will attempt to solve those problems with new ways of representing the space in the next coming lectures. Any questions on any of these sort of bigger points or the topics covered in this lecture before we go ahead and dive into assignment 1? Seeing a shaking head no in chat or in our 1 video. I appreciate you. But I want to give just a little bit more in case anyone is typing in the chat right now. Do a little dance. Okay, seems like we're all right. So in that case, we're going to go ahead and move from these lecture slides into talking about this assignment. So if you go to eClass right now, actually, I can just do this, right? So obviously we have some answers here. Let's go over to here. If you go into eClass right now, your eClass will look a little different than mine, as we've talked about previously. You can scroll down and find, aha, well, would you look at that? We have assignment 1. If you click on assignment 1, you'll see that there's a PDF and a .zip. So if I go ahead and download this PDF, first off, now I can go back and show you this PDF. There we go. Now, let me move a little bit more over so that I'm not obscuring anything. Okay, so let's talk through this PDF real quick. Can I do this a little better? Yeah, there we go. A little bit more clear. So this is a long PDF, pretty obviously. It is 6 pages, which might be quite a bit in terms of what you are used to from assignment instructions. Maybe it's not. Maybe 6 seems reasonable to you. But the reason why this is so long is because I'm having to introduce a lot of stuff. What I'd recommend doing for your own purposes is to read through this from the instruction section, which if we scroll down, is right here. I would read through the instruction section first, and then I would go back and read through other sections as it's helpful. So the idea here, I'm not going to read this for you. You can all read, is that obviously you need to have downloaded and installed Unity. You need to download and install the assignment1.zip file. You need to open it. So let's go ahead and do that. Let me follow my own advice here. So I'm not going to show you clicking on getting things open in Unity. I'm just going to go ahead and open up Unity. I'm not going to do the thing where I share my desktop in this case. Yeah, okay. I'll just go ahead and do the thing where I share my desktop. So we'll just get to watch the infinite again for a little bit. Hey, look at that. It's the infinite. All right. Scroll. Scroll. Hey, look at that. 1,000 million infinite Matthews. All right. Okay. So if we go back over to here, to Unity, this is our default setup for assignment 1. By default, you'll open up probably scene 1. Now, as a reminder, if you hit play, you will get and some obstacles showing up and an entity, in this case, Pac-Man. Look, there he is. If I click, by default, Pac-Man is just going to try to straight line distance directly to my mouse, as you can see on the bottom left there. If I click, try to click on the other side of an obstacle, then Pac-Man will get stuck. Now, Pac-Man can get off some obstacles, but not all obstacles. So our problem is going to be, okay, let's fix this, right? Let's give a space representation so Pac-Man isn't just doing a straight line distance. In terms of how we do that, what we want to do is we want to open up the grid handler script. So let's jump back over to our preview real quick. Once you've sort of looked at scenes 1 through 5, which I'll let you do on your own, you can go ahead and mess around a little bit, but your goal is to modify the gridhandler.cs, which is the script I just opened, to complete the create nodes function. So let's go ahead and take a look at that. So gridhandler.cs is right here, and you can see that we have the create nodes button, or not button, we have the create nodes function, and then we have 2 comments here. We have assignment 1 edit below this line, and assignment 1 edit above this line, okay? So here is where you're going to need to do the grid creation based on the pseudocode that I gave you. You can make changes elsewhere in this script, but do not make changes anywhere else. So let me go ahead and close everything else right now. So by default, you can see that I've given you a for loop where we're going to go from the left side of the screen to the right side of the screen. And we're going to update in grid size. This is going to give us where each X is a potential position we could put a grid cell. So for now, I'm going to go ahead and uncomment this code that I've given you. Now, notably, there's no Y variable, so I'm going to put just a 0 here. And let's go see what this code does. No, I don't want to install an update. Let's go back to Unity. Unity, please. Thank you. Now, if I hit play, it may not be obvious from the game view, but in our scene view, we can see we now have a grid, right, that we can take a look at. And if I click somewhere in our game view, Pac-Man will now move along this grid. Now, because there is now a grid, Pac-Man won't move off the grid. So I can click off the grid any which way or form, but the best Pac-Man can do is the closest grid position to the place I clicked, okay? I'm going to have to show you the infinite for a second. Let's see here. No questions? Okay. Let's jump back over here. So your goal is going to be to, from this sort of simple, humble beginning, right, you want to give us the entirety of the grid. Now, I can go ahead and give you the sort of second for loop because this is trivial, right? It's just in the pseudocode. Let's go ahead and make this change. We want this to instead be over the Y dimension. Y bound instead of X bound, which is just giving you the boundaries of the scene. And that's it. So now we can just do X and then Y. So now if we run this code, we can go ahead and see, if I zoom out, oh, whoops, I slightly mixed up the code. Can you see where I had a X is less than this, it needs to be Y is less than this, and Y plus equal to grid size. Okay. Let's try that again. Now, if I hit the play button, we can see that, aha, we've got a full grid. Problem, that grid is going to include areas that are clearly in the obstacles, which means that if I click in an obstacle, I'm going to try to walk directly through it because there are grid cells there. So the goal is going to be to only run this line right here if this grid cell position would be valid. Okay? That's the entirety of what you need to do. I appreciate people pointing out that I forgot to do the whys. Any other questions? Can you show again how to open the folder in Unity? I never showed how to open the folder in Unity, but sure, I will show you from scratch how to open the folder in Unity. So we click on Unity. By clicking on Unity, we're going to get a pop-up that looks just like this. And I am going to be able to just go ahead and select assignment 1. You also see assignment 1 solution there, along with a number of other things. But we're not going to worry about that. You're not going to see this. So instead, you're going to have to click Open. And then from Open, you're going to be able to have to find in your sort of whatever browser you're using, for if you're Windows or Mac or Linux or whatever, you're going to have to find where your assignment 1 folder is and just click to open it just like that. Okay? It's pretty straightforward. You can also open it by just double clicking on one of the scene values. So for example, if you can just find, if you can just find a scene1.unity, if you just double click it, Unity will automatically open the project. I can show you all some of the other scenes. We've got this one, for example, scene 2. We've got this one, for example, scene 3. We've got this one, for example, at scene 4. And then we have this one of example for scene 5. Okay. So the only other thing that I especially wanted to do was I wanted to introduce you to the 2 other scripts that you're going to especially be using. They are obstacle handler. Obstacle handler right here. There's a lot of stuff going on here. It's mostly commented out, and all of the important functions are given to you, not here, but in the assignment here. So we go over all the important things. So for example, do a line segment defined by 2 points, does it intersect with any of the obstacles? Is a point, the given point, in any of the obstacles? Et cetera, et cetera, et cetera. If I wanted to call obstacle handler in the code, I would just go ahead and in grid handler, I would write obstacle handler dot instance dot, for example, point, what's the name of that? Point in obstacles, and then pass in lock, for example. And that will give me a true or a false about whether or not this position is in an obstacle, okay? You might also find it helpful to interact with Polygon directly. So all the obstacles are all defined as polygons. And you can also instantiate, say, a grid cell as a polygon, or the bounds of the map as a polygon. A polygon is just, from geometry, any set of points that define a closed space. And this has a number of member functions as well that you might find helpful. You can also dig into the Polygon script itself. It's all fairly well compensated as well. It looks like the grid doesn't cover the whole camera window. Is that fine? Yes, it's just the X bound and the Y bound that define that. It's not the camera window. Now, notably, I had an issue last year. You can change the camera window size as well. So if I wanted to, I could just change this to like 1, for example. I had a problem last semester, right, where people thought that the bounds of the camera, as you can see right here, these are the bounds of the camera, this line right here, very, very thin line, that was the bounds of the scene. That wasn't true. So instead, we've changed to make clear that the camera is entirely distinct from the bounds of the scene. All right. Okay. In that case, I'm going to move on to everybody's favorite part of any assignment, the grading. I think the thing that people primarily care about. So the way that grading is going to work is you have a total of possible 10 points you can get on this assignment. In each, you'll be tested on 5 scenes, the 5 scenes you're given, and then 5 withheld scenes. For all of these scenes, you can lose up to 1 point if your map has at least one cell, it just has to be one cell that intersects with an obstacle or goes outside the boundaries of the map. Those are just defined, again, by X bound and Y bound. There's no trick there. The autograder is going to be used. I'm not going to be hand grading here. This is just the setup. What it says is what it is. This is exactly how you're going to get these points. Now, notably, that's a little bit negative because if you just make one mistake on a single map, that's a full point lost. But on the other hand, it's a positive in terms of if you have lots of mistake on one map, at most you can lose a single point, okay? This is a little bit of a course grading. So, right, it's a very big jumps in grades for this assignment, but that's just because this is really just set up to get you working with Unity and working with C#, okay? This is not set up to be a big challenge. Now I say that, and the next assignment is going to be much more challenging than this one. And because of that, the extra credit for this assignment, each class or each assignment will have extra credit. The assignment for this extra credit is potentially the hardest extra credit in the course. You will optionally receive up to 1 point of extra credit for completing navmeshhandler.cs. Okay, I can go ahead and show you the default of what navmesh looks if we go ahead and open up our 1 extra credit scene. So if I go in here, oops, that's the navmesh handler. I want the extra credit scene. And we can see that by default, oh, this is going to take a second. Here we go. Here's our behavior of our navmesh handler. We'll get into, I'll describe in class what navmeshes are in a bit, but suffice to say, this is bad. This is not a good navmesh. So your goal is going to be to change navmesh handler, if you want to attempt the extra credit, to do better than this. In terms of how to get the points, you can get up to 1 point of extra credit, which is equivalent to 1 point on your final grade. You will gain half a point if you can successfully create a valid nav mesh, which means no meshes intersect with one another or any other obstacles. And you'll gain another 0.5 points if your mesh contains at least 1 mesh with 4 or more points. This is challenging. That's right, it's 2 separate things. So the first half points is the easiest one to get for. This is the more challenging one. We'll get to why when we introduce nav meshes early next week. Your navmesh handler script will be tested on 1 of the withheld maps. So I'm only going to check it on 1. If your navmesh handler performs better than the given default behavior, even if it doesn't manage to do the other 2 things, I will give you 0.1 points for just attempting the extra credit, right? So it is in your best interest to try the extra credit, even just a little bit, because you'll get at least a small little pittance of a point, okay? Any questions on that? Not seeing anything. Oh, somebody sent a screenshot. That's fine. As I said at the beginning of the lecture, it's fine if, okay, you don't have to send me the same screenshot over again. A screenshot was sent about that being a different Unity version. The Unity version does not matter. You can go ahead and just say open it anyway. That does not matter. You would just get 0.1, not 1.1 for extra credit. The 0.1 is if you don't get any other points for the extra credit, but you do better than the default behavior. Okay. I'm going to say we're probably not going to have a lab for this assignment. But what I will do is I will release a video, which is going to go over the assignment in a little bit more detail sometime next week, because I know how students work, and students generally work at best a week before an assignment is due. Okay? All right, so class is technically done here at 11:50, but as per the usual, I will hang out as long as there are additional questions in the chat. Do we have a lab this week? No, as I just said. All right, no other questions. One other thing, if people are just hanging out and there's no other questions. For example, let's take a look at scene 1. These obstacles here, let me go ahead and full screen. These blue obstacles are just defined by code as well. So you can change them. Even though I've only given you 5 scenes to test on, you can actually make changes to these scenes to approximate additional ones. So for example, this is the script which is defining the 2 obstacles for scene 1. So we have the triangle up here, 3 points, and we have the, square down here, which is 4 points. So for example, if I go ahead and just say, get rid of one of the points of the square. If I rerun scene 1, now let it recompile, we can now see that instead of a square, it is a right triangle, right? Similarly, I could add a point to the triangle that would give it a, that would instead make it a square, right? Or a, who knows, any kind of shape. The only important thing is that you don't have obstacles that have intersecting lines. So you can't have like an X-shaped obstacle or anything like that. That'll break some of the basic computation in the code. But feel free to mess around with that to sort of give yourself harder maps to work on. Do we have lab tasks in the future? There will be labs assigned. I will always give you a week notice if there's going to be a lab. But notably labs, sorry, I shouldn't say they're assigned. Labs will always be optional. You never have to go into a lab. They're always just going to be for extra help for an assignment. Where to open the code? I mentioned that just a second ago. You can open Unity and then you can, oh, do you mean to open up a script? Well, if you don't have Visual Studio installed like I do, and you just like double click on something, you can instead find the script. So for example, gridhandler.cs in the folder that you download, and then from there, open it in anything, say Sublime Text, for example. And then you can just make changes here. I do recommend downloading Visual Studio as it will give you readouts in Unity that are helpful. So for example, I could go ahead and I could print out with debug.log the vector3 position, every vector3 position I'm looking at. This is going to print us out as long as I'm using Visual Studio, so we're all hooked up nicely to Unity. Sometimes it will work without Visual Studio being hooked up. It really depends on your install and some of those security preferences. But if I go ahead and hit play, if we look at the bottom left here, which I can double click to open up, oops, then we can see every single position that we are considering when it comes to a grid position. So that can be very helpful for debugging. Can I please show that again? By that, do you mean opening up a script, or do you mean adding a debug line? Where to open the code? Okay, so again, if you've downloaded assignment 1, you're gonna see assignment 1 like this. If you go into assets and then homework 1, you can find Grid Handler from there, and then you can open Grid Handler in anything you like. In Unity, if you have Visual Studio installed, if you double click a script, it will just open it up in Visual Studio. Can I quickly explain again which grids are valid? So it's a very straightforward. It's if there's any overlap in terms of the grid and an obstacle. So if there's any overlap between a grid and any part of an obstacle, it is not valid. So for example, right, this top left, or this grid up here is also not valid. Ooh, that's not a good color for showing anything. Let's go ahead and change that back to a nice bright orange. So this is not valid, right? Obviously, this is not valid. This is not valid. Ooh, fun shape. This is not valid. This is not valid. This is not valid. This is not valid because we've got a little corner. This is not valid. Okay? Okay. Any other questions? I'm gonna go ahead and stop sharing my desktop. Boop. And just sit here in the void, asking if there's any questions. I can also just pop back over to here. Now I'm tall and my background is wrinkly. Okay. Well, if there's no other questions, I'm going to talk really slowly in case there's another question. But if there's no other questions, I'm going to go ahead and stop the meeting. As per the usual, feel free to ask questions on the Discord. There's a channel specifically for assignment 1. How do we access the OBS? The what? The obstacle. The obstacle. That's an obstacle handler. I would recommend reading through assignment 1. So The obstacles are held in, let me grab this, and I can go ahead and turn this back on. The obstacles are held in obstacles, which is just a public array of polygons that represents all the obstacles. You can reference those with obstacle handler .instance .obstacles. But again, I do recommend actually reading through the assignment notes. You'll get a lot more of that. Would you be able to upload the lecture of today? I will be uploading the lecture of today, as per the usual. I'll send in an email once it's all online. Okay. If there's nothing else, I'm going to go ahead and stop the meeting. And again, feel free to send emails or Discord. From what I can see in the documentation for Unity, you can set the external script editor such that basic debugging functionality is available through different editors like VS Code, Sublime, etc. for the stuff like the debug log to work. That's true. I just didn't want to get into that for most of the students, but if you want to mess around with it, feel free. Just the easiest way is just using Visual Studio. I've also found that that can be a bit buggy. It claims that it will just work, and often it doesn't. But you can try it. You might have better success. All right, really got to cut it now as I have another meeting to go to in 2 minutes. Thank you all. Great questions. Shoot me an email, shoot questions on the Discord, et cetera, if there's anything else. And otherwise, I will chat again Friday. Bye all.